Hello all, in this tutorial we are going to build a simple token swap program on Solana. It's going to be a decentralized exchange. We are going to use Anchor framework for building the program, and for swap logic we are going to use the AMM constant product formula. We'll be seeing about it in a while. And for any decentralized exchange, the key operations are creating a pool, adding the liquidity to the pool, and swapping the tokens. Let us discuss about each operation. First, initializing a liquidity pool or creating a liquidity pool. In our program, we'll be creating a liquidity pool. A user can come and create a liquidity pool by providing the two tokens, a mint A and mint B. We'll create a pool with two tokens, and while creating the pool, we'll be creating two token vaults, one for token A and one for token B. Those vaults will be storing the tokens, and this is going to be a PDA, a program derived account. Next, once the pool is created, we have to add the liquidity, and now again any of the user can add the liquidity to the pool. They can have token A and token B. They can add the liquidity. The added liquidity will be stored in the token vaults of the liquidity pool. Next, swapping the tokens. Now the user who want to swap the tokens, he'll enter the number of tokens he want to swap, and he'll get back the exchange token. For that, we're going to use the constant product formula. The base formula for that is this one, and we'll be using this formula to calculate the output amount. Okay, here x and y are reserves, the reserves of the liquidity pool vaults, and we're going to ensure that the output amount is always greater than or equal to the minimum amount of the output. So while exchanging, the user will provide the minimum amount of the output tokens. We'll always make sure that the output amount is greater than or equal to the minimum amount. Now let's get to the code. So here I've created an Anchor project. And in the programs folder, in the project name folder, in src we'll be having lib.rs. In that we'll write the logic. So for any Solana program, we'll be having four main parts. First, we need to define the data structure, the structure of data which we are going to store on the chain, and the instructions and the handler functions. A module with handler functions and error codes, if any. Right now, let us see the data structure. We are going to create a pool, right? So this is the data structure for creating the pool. For each pool, we'll be having the authority. Authority is the one who is going to create that pool, and mint A and mint B. These are the tokens, token A and token B, and we'll be storing the bump. We'll see about that in a while. Okay, this is the data structure. We'll only have the pool data structure because the rest of the operations will be performing them using the transfer, right? We'll be using the CPI of transfer. Done. Now let us see the handler functions. We have initializing a pool, adding the liquidity, and swap. Now let us see the instructions for each of them. First, let's see for initializing a pool. Let me open the instruction. So these are the instructions for initializing the pool. For any pool, there will be an authority, the person who is going to create that pool, and will be creating an account for that. We'll be using the seeds. So seeds for this is pool followed by mint A and mint B. So we'll get mint A and mint B, the tokens, token A and token B. We'll create a account for that pool, and we'll also take the mint A and mint B as the inputs. And once we get them, we'll also create two vaults, one vault for token A and one vault for token B. So these vaults will be storing the tokens. If we add a liquidity to the pool, these vaults will contain them. Okay. Now again, these vaults are also the program derived accounts. If we see here, we have a payer is authority and the token mint is token A. So this is going to be the mint A account. This is going to be a token account, which is why we have provided token account here, and token mint is mint A. So this account is for token A, mint A, and this is for token B, that is mint B. And the authority is going to be the pool. So the pool account is going to control this, okay? And the seats, vault A and followed by the pool. Done. We have the vaults. Next, we're going to use the token program to transfer the tokens. Done. And system program. This is the instruction for initializing a pool. Let's see the handler for that. Okay, if you see, we'll get all the things in this instruction. We'll take the pool and we'll assign the authority. We'll assign the authority mint A, mint B, and we'll also store the bump. Done. This is how we initialize a pool. A user will come, he'll provide the mint A, mint B, and he'll initialize the pool. Done. Now let's see the next instruction, that is for adding the liquidity. So any user can add the liquidity. So for that, user is going to be the signer and he'll provide the which pool is going to use. We'll just derive that using pool and mint A and mint B. Here we are not creating the account, we are using the existing pool account. But in case of initializing a pool, we are passing init because it's going to be the first time we are creating that. That's why we'll pass init over there, right? In adding liquidity, we'll use the existing pool account, right? Now, the user will also provide the token accounts of token A and token B. Then we'll also provide the vaults. Okay, these vaults are gonna contain the tokens, right? So we'll also provide the vaults. Since we are gonna perform some transfer, we'll use the token program in this. Now let's see the handler function for this. Add liquidity. So here if you see, we'll get the instruction and we'll also get amount A and amount B, token A amount and token B amount. So here what we have to do is we need to transfer the tokens from user to the vaults because we are creating the liquidity. We are adding the liquidity to the pool. It means you have to transfer the tokens from user account to the vaults. So if you see here, first we are creating our transfer struct. From is from user token account and to is vault A. That is the account that contains the liquidity pool tokens, and the authority is going to be the user. And now here we are going to create the context for transferring. It takes the CPI accounts, this one, and we're going to use the token program. We're going to use the token program. Next we'll transfer. Amount is amount A. So we are transferring the token A amount to the vault A. Done. And next we have to transfer the token B amount. The same logic, we'll create the transfer struct, we'll use the CPI program of the token program, and then we'll transfer the amount, that is amount B. So till this point we have created a liquidity pool, we are adding the liquidity to that. It means we are adding two tokens to the vaults. Done. Now the next instruction is the main logic, that is swap. Now a user will have to swap, right? So he's going to be the signer and he'll select the pool and he'll provide the user token A account, token B account, and the vaults. It's almost the same because the core logic will be doing it in the handler. So for transferring the amount from vault to user and user to vault. So the inputs for this is almost same as the inputs for adding the liquidity. So we'll take the user, the pool, user token A account, token B account, and the vault A and vault B, and of course the token program for transferring. Right, now let's see the instruction, the handler function. Here we'll receive the amount in the input amount user is going to give, and the minimum expected output amount, and a flag. This flag is to specify whether we are swapping from token A to token B or token B to token A. Okay, say boolean flag. Now here we'll just get the balances from each of the vaults. We'll get the vault A and vault B, right? We'll get the balances from each vault, and next we have to calculate the output amount. So for that I've written a helper function. Let's see that. So this helper function logic is same as this formula, this one. Okay, the orange one. Okay, so here we are multiplying, we're adding, and finally we are dividing that. So it is same as this. Okay, we'll get the output amount. So this formula will make sure that the ratio of the tokens in the pool always remains the same. So that's how it will give the output amount. Now let's get back to here. Yeah, now here once we got the output amount, we always have to make sure that the output amount is greater than or equal to the minimum expected output amount, right? The user will also provide the minimum expected output, right? If not, we'll just return an error. Done. Now let us perform the actual swap. So here for swapping we need to transfer token from user to vault, and then the exchange token from vault to user. So here we have two things. If user want to swap from A to B, this is the logic, and else if you want to swap from B to A, this is the logic. It's the same, but we'll just swap the tokens. So here if you see, first thing we have to do is transfer token A from user to the vault. Transfer token A from user to the vault. So again we'll create the transfer struct, and we'll use the token program, and we'll transfer that amount, the amount input which user is giving. We'll transfer that to the vault. If you see here, the to account is going to be the vault that is owned by the pool. Then we have transferred tokens from user to vault. Now we want the exchange tokens from vault to user, right? Here we want the exchange tokens from vault to user. Here from is going to be the vault B. Here we need a signer. So here this vault, the vault which we are seeing, is owned by the program derived account, that is pool. Pool is having the ownership. Pool is having the authority of the vault. So that's why we're gonna get the PDA signer. So for that we'll just take the bump, and we'll again derive that PDA signer. Once we get the signer, then we'll use that signer to create the CPA context and transfer. So if we see here, we're creating the PDA signer, that is the authority is going to be the pool. That's why we'll use this, and then we'll create the transfer struct, then CPA context by providing the signer, that is the PDA signer, and then we'll transfer the tokens. Else it's vice versa. It's the same, right? This is how we perform the swap logic. Done. Now let us build this. I'll open my terminal and anchor build. So I've already built it once, that's why it will not take much time. If you are building it for the first time, it will take some time. Once we have built it, let's deploy it on local Solana testnet. I've started a Solana testnet in my system, and now let us deploy it. Anchor deploy. A Solana testnet is running in my system. We need to install the Solana CLI and just run the command Solana test validator. If we run this command, it will start the local testnet validator. I've already started that. Now let us deploy it. Yeah, our program got deployed successfully. Now let us test our program with a client. So here in the app folder, I've created a client.ts file. In this, we're going to write the logic to test our program. So the steps are going to be the same. We'll create a pool, add the liquidity, then swap. But here we would need several accounts in order to perform that. So yeah, once we get into this client.ts file, we'll also be using one thing, that is the ideal file. Once we build that, we'll get that ideal file. It will be in this target ideal folder. We'll be using this. This will contain the, let me show that, the instructions and the program address, program address. So here we'll use that. We'll use that ideal. So here I've created a class called swap client, and there are several parameters in this. Let's discuss about each of them. But before discussing this code, let me run this and give a quick demo of this so that it will be easy to understand the code. So I'll just say npx.tsc. I'll run this. So now, so here we are running the client. So here the scenario is that we'll have a liquidity provider, a person who will provide the liquidity. That person, that account will be having both token A and token B, and we'll have a trader. We'll have a trader. He will only have token A and he wants to swap for token B. This is a scenario which we are gonna demonstrate now. So for that we would need some test accounts, right? We would need some test accounts. So first let's create some test accounts. We're going to create 4 accounts. First one is payer. We are going to use this account for creating the liquidity pool, and then next account, that is liquidity provider, the person who is gonna add liquidity to our pool, and then the trader, the person who's gonna swap, and the mint authority. We are gonna create the tokens mint A and mint B using this mint authority. This mint authority will create those tokens. So first let us create the tokens. We have token A and token B. We created the mints for both of them. Now let us create the accounts for token A and token B for the liquidity provider. So for liquidity provider, let's create the accounts. We have created token A account and token B account. Once created, since the liquidity provider will have both token A and token B, what we'll do, we'll mint 1000 tokens of token A and token B to the liquidity provider. Till this point, we have created the mint, we have created the accounts which we need, and we have provided the tokens to the liquidity provider. We have minted some tokens. Next, we need to mint some tokens to the trader account also. So here trader has only token A and wants to swap for token B. So here we'll mint 100 tokens of A to the trader. So trader will have both the accounts, token A account, token B account, but we'll mint 100 tokens to token A, not of token B. Okay. Now we have the scenario, right? Now let us create the pool. So here, once we create the pool, so here the pair is going to create the pool. Pair is going to create the pool. Once the pool is created, we'll get a PDA for pool. Each pool will have 2 vaults for token A and token B. We have 2 vaults, vault A and vault B. Once we created the pool and the vaults, next thing is to add the liquidity. Now we have the liquidity provider. He is having 1000 tokens of each token A and token B. Now he will add 50 tokens of token B and token A to the pool. So liquidity is added. Once added, the balance of the liquidity provider will be 950 and 950 because 50 tokens are added. Now the vault balance will be 50 tokens of each, token A and token B. Till this point, we have added the liquidity to our pool. Now the next thing is the trader will enter the point. He will have to swap some tokens of A to token B, right? So here trader swapping 10 tokens of A for token B. So here if you see the balance of the trader before the swap is having 100 token A and 0 tokens of B. Here we are printing the expected output using the constant product formula. We'll see that this is just the expected output. Now once the transaction is completed, the swap is successful. If you see the balance, you can see token A we have 90 tokens because we are trading 10 tokens for token B, right? So 90, and in output we got 8.3 token B, right? Now let us see the pool balance. Initially it was 50 of token A and 50 of token B. Now token A is 60 and token B is 41, right? Now again here the trader will try to swap from token B to token A, again the reverse. So before the swap, let's see the balance. Token A 90, token B 8.3, and this is the expected output. Once the swap is successful, you can see token A 94 because 4 tokens got added, and token B 8.3 minus 4, it will be 5.3, right? Now if we see the pool vault balances, token A is 55 and token B is 44. Previously it was 60 and 41, now it's 55 and 44, right? Now let us see the code. So here first we'll initialize everything, that is we'll create the key pairs and the test accounts. So here we'll create some key pairs. So let me show that. In the constructor we are creating some key pairs, 4 accounts: payer, liquidity provider, the trader and the mint authority. Done. Now we'll airdrop some tokens to them. Next we're going to create the token mints, and we're going to set up the liquidity provider account and the trader accounts, the token accounts. Done. Next, once initialized, next we are going to initialize the pool. Let me open this. So here if you see, we're going to create a pool PDA account. We're going to create the vault A and vault B, and then we'll call the function, the initialize pool, by providing all the inputs, and we'll call the RPC. We'll do the transaction, right? That's for initializing the pool and adding the liquidity. Here adding liquidity, it takes amount A and amount B, and the pool, which pool the user is going to add the liquidity, and the vault accounts, right? So again here we'll again do the transaction. We'll take the inputs to amount A and amount B, and we'll add the liquidity. So here in order to get the associated token account, we'll just pass the mint A and the liquidity provider. Then we'll get the token account of this liquidity provider for mint A and again for mint B. And yeah, we'll do the transaction by passing the values, and we'll call the RPC. Done. Next thing is, once created the pool, added the liquidity, we'll do the swap transaction. Here if you see, swap is taking pool PDA, vault A, vault B, and the input and minimum expected output. And true means it is swapping from token A to token B. It's a flag. Let's see this. So again here we'll extract the token accounts of that trader. We'll pass the inputs. Swap the function, the input amount, minimum output amount, and the flag A to B or B to A. Done. We'll provide the necessary accounts, call the RPC. We did this swap transaction. So this is how we write a client and do the transactions. That's it for this video. Thanks for watching.